Now we discuss linear bounded automata, which we denote by writing LBA, and since this is the automata, we can say LBAs. What is an LBA actually? LBA, here actually linear bounded automaton, which we denote in writing short LBA, is a 5-tuple m q sigma tau q0 delta, which is same as the non-deterministic Turing machine except in the following respect. So once you talk about the non-deterministic Turing machine, then you know that here again q finite sets, sigma input symbols, finite set of input symbol, tau here you have the finite tape symbols, everything is same, blank is not in the tape symbol. Q is not going to include alt state. HA and HR are not the member of this set. Q0 is the initial state, and transition functions we have seen in case of the non-deterministic Turing machine is the same as here. So in what manners it is different? So this is, we are using two extra tape symbols, say left angular bracket and right angular bracket, and these two tape symbols are not in the set tau. So your Turing machine or LBA, which is we denote by writing M. So M begins with the configuration you are in the state Q0, which is the current state, initial state. At the square 0, we have the left angular bracket, and your tape head is scanning the symbol at the square 0, which is the left angular bracket, and immediately after this, means from this square 1, you are having the x, and immediately after the input you have the right angular bracket. So this is the initial configuration. So this initial configuration says that your machine is going to start from the initial state, and your tape head is scanning the symbol left angular bracket, and immediately after the left angular bracket you have the input, and after the input you have the right angular bracket, and everything after that is blank. So actually you are enclosing the x within these two symbols. During the moves, during the moves, M is not permitted M is not permitted to replace symbol left angular bracket or the symbol right angular bracket. So during the movement, we are not going to replace this symbol with any other symbol, means even you are not able to delete the symbol, means you are not able to replace these two symbols with the blank, or you are not able to replace these two symbols with any other type symbols. So during the moves, M is not permitted to replace the symbols this or this. So you can say replace the symbols left angular bracket or right angular bracket. Also, M is not allowed M is not allowed to move left of the symbol left angular bracket or or you can say right. So M is not allowed to move, not allowed to move left of left angular bracket or right of the symbol right angular bracket. So these are the restrictions actually. So these are the restrictions we have. Okay. So an LBA is same as the non-deterministic Turing machine. And what extra we are going to add in the LBA? So we are using two extra type symbols, which is the left angular bracket and right angular bracket. And M begins with the configuration like Q0, and your tape head is scanning the left angle bracket, and immediately after this symbol we have the X, and immediately after that we have the right angular bracket. During the moves, M is not permitted to replace the symbols, these two symbols, and also M is not allowed to move left of the symbol left angular bracket or right of the symbol right angular bracket. So your LBA start with this configuration actually. This is the situation. So you have the symbol at the square 0, and your tape head is scanning this symbol, and immediately after this, after after the square 0, we are having the input X, and as soon as your input is going to exhaust, and we are having the symbol right angular bracket, and everything is blank. Okay, after that, so your input is here. This is the start configuration. So your input is here, and these are the squares containing the exactly the one symbols of these input. So this is the initial configuration. Okay. So this is also the NTM actually, and this NTM, in this NTM actually we are using the two extra tip symbols, and we have the restriction that we are not supposed to replace these symbols with any other symbol. Means even you are not able to delete these symbols, and your input is bounded by these two symbols, and your Turing machine is allowed to work within this bounded region. So this is the bounded region. You have bounded region where this within this bounded region actually you have to work. Beyond these two regions you cannot work left side of the left angular bracket, and also you are not allowed to work after the right angular bracket. So we have the theorem, we have the language L. So if L is the context sensitive language, if L is context sensitive language, then there is an LBA accepting L. Means for every context sensitive language, we have some LBA. So this is the device actually for accepting the context sensitive language. So why what why it is so? So you you see that in case of the context, once L is context sensitive language, then we have the context sensitive grammar for this language. So L is, if L is context sensitive, then we have the context sensitive grammar. So in context sensitive grammar, what kind of production rules are there? Once we say the CSG, which is the context sensitive grammar, context sensitive grammar, which we denote by writing context sensitive grammar, CSG. So in context sensitive grammar, we know that we have the production rules, like we have alpha derives beta, and with we have the condition length of beta is more than or equal to length of alpha. So if you have the context sensitive grammar, the production rules will be of the form alpha derives beta, and alpha is what? Alpha is any string of terminals and non-terminals both. Beta is also the strings of terminals and non-terminals both. Alpha should contains at least one variable, with the condition that the length of beta is more than or equal to length of alpha. Means the right hand side string beta must be of the length at least alpha. This means what? The production of the form like A derives null is not allowed in this kind of grammar. Why it is so? Because the length null is of having length 0 and A, here you have only one non-terminal is of length 1. So this string of having length 1 and this is the string of this string has length 0. So this is not permitted in the context sensitive grammar. So we have actually you are not able to delete the symbols in the context sensitive grammar. That's why this tells that the length of beta must be more than or equal to length of alpha. In more general, you can say the rules like this. You have alpha a beta can derives. You can write the rules in more clear way. Alpha a beta is replaced with alpha x beta. Now here you see. So alpha and beta, again alpha and beta are the strings. They are the strings of terminals and non-terminals both. So these belongs to, say, terminal symbols we denote by writing V, and non-terminals, which is the input symbol alphabet, we are denoting by writing sigma. So this is the string of terminals and non-terminals both. Here A is what? A is the terminal, A is the non-terminal symbols. So V is the non-terminal here. So alpha beta can be the string of non-terminals and terminals both. Sigma, elements of the sigma is the terminal symbol. So non-terminals, this is the string of terminals and non-terminals both. And A is what? A is non-terminal symbols. So A belongs to V. So this is the non-terminal. And X can also be the string from non-terminals or terminals both, but condition of the length regarding the X is the length of X must be greater than or equal to 1. This means the length of X can't be 0, means X cannot be null, means X is not null. So we have X is not null. Okay, so this is the situation. So in this case, what this context sensitive grammar is telling, it says that if you have the left context is alpha and right context is beta, then you are actually able to replace this A into X. So that's why this is the context sensitive, you know that. So this context sensitive production says that whenever you have the left context is alpha and right context is beta, then you are able to replace A with the string X. And X can be single variable or X can be composed any strings from variables and terminals both. So it can be the string of variables, or it can be string of terminals, or it can be string of variables means non-terminals, or it can be string of non-terminals and terminals both, but X cannot be null. This says that the length of this this denotes that the length, this is the right hand side string, the length of right hand side string is more than or equal to length of the left hand side string. So this tells that alpha a beta, the length of alpha a beta is what? And you have the you can say you have alpha x beta. So length of alpha x beta is having more than or equal to length of alpha a beta. So this is why it is so, because X is not null. So X can have only single variable or any terminal symbol, then the length will be same, and this X can have length more than 1. So this is with this discussion we know that once once you are supposed to go for some generation of the some strings with the help of the context sensitive grammar, then the working length will not be more than the length of the given string. Means if you are given, so if you are given the string x, and if you want to generate find the derivation tree, or if you want to apply the production rules of the grammar for generating the string x, say the length of this string, maybe anything, say length of this string is n. So whatever starting from the initial or start symbol, which is the start symbol of the grammar, and your every sentence, valid sentence, starts with the start symbol. Starting from the start symbol, you may have some strings, say z, and z can be what? Z can be any strings from the set, either v union sigma clean star. So z can be any string of this set, but see, this can't be null because you are not able to delete the symbol. So what is the condition? The length of this z, length of this z, length of this z will not be. So always you will have the condition that the length of the string z, this is the working string z, should be either less than or equal to n. As you are supposed to find out, you are supposed to generate the string x whose length is n. So once you start from the start symbol in the CSG, context sensitive grammar, in the context sensitive grammar, then this is the working string. The length of the working string will not be more than n. Why it is so? Because if length is more than n, then actually you are supposed to obtain the string x, and for that actually you must have some production rules, then can delete some symbol. But in this case, it says that length of beta must be greater than the length of alpha. In every production rules, you will have this situation, and hence once you are able to increase the length by n, more than the n, then there is no way to delete the symbols. And that's why in the context sensitive grammar, whenever you are given some string and you want to generate that strings with the help of your context sensitive grammar whose length is n, then whatever every working string length must be less than or equal to n. This is, and hence you can say that that's why you are telling that okay, whatever be the length of x, and you are not supposed to take more symbol, you are not supposed to have working strings during the generation of the string. You will not have the working string more than the length of the x, and hence you don't require more region, and this x has some fixed region. That's why actually you are bounding with the two symbols here. So that's why if you have the context sensitive language, then for accepting the context sensitive language, you have some LBA, and in the LBA actually you are bounding the region, and you are in the tape, the portion of the tape you are bounding, and you are asked that okay, you have to work within this bounded regions. And if this is the context sensitive language, then you will be able to process with that region. You don't require extra regions for that, and that's why this is, we need two extra tip symbols to bound the region, and hence this is the actually the linear bounded automata. So for any context sensitive language, you have some linear bounded automaton. So let us see the examples. Okay, so we are supposed to construct the language. We are given the language L, A, N, B, and C, and greater than or equal to 1, and we need to construct the LBA for that. Okay, so how we can construct the LBA for this? And we know that this is the context sensitive language. Okay, so we have the context sensitive grammar. We have seen the context sensitive grammar for this also. So how we can construct for the LBA? So your LBA, whenever you are going to construct, then your input is stored in the tape, and that input is bounded by the two symbols. We know that means you have the tape, we have the tape, okay, you have the tape, and this is the square 0 in the tape, and we have, say, for example, if you are given x, which is AA, BB, and CC. If your x is given like this, then your input will be in the tape will looks like this. This is the square 0, which is containing the left angular bracket, and your tape head is scanning the symbol square 0. Immediately after the 0, we have the input, okay, then BB and C and C. And once you immediately after the C, after the input, we have this symbol right angular bracket, and everything is blank here. You know that this is in fun. So here actually this is what, this is the X. This is, so this is the initial contents of your tape, and your tape is actually acting as the input tape also. Okay, so this is the situation, and your LV is starting from the initial state Q0. So how it is going to start? You have, how you can work, how you can do actually. So it is very simple actually. What you can do, A, B, B, C, C. You just need to match the number of A's, number of B's, and number of C's. You must have the same number of A's, same number of B's, and same number of C's. So one way to do this is you can change the symbols one by one. Like you can jump from the beginning to the end, and if you are starting from the beginning, then change this lowercase with some other symbol so that you can remember that okay, you have matched this number with other. So right, if you have the A, you can change with X, symbol X, then go to the right, and whenever you are having the B, you can change this, say this is, you have changed to the X, then if you are encountering the B, change to the Y. So one A, you have the A is converted to the X, then same number of B you need to convert to the Y, then you will have the C, and you are, say you are going to convert the one C at the Z. So exactly one number of A, one number of B, one number of C you have converted, and come back to the this one and go for the next A, and again next A you need to convert to the symbol like X, then go for other B, and then you go for the other C. Okay, again you come to the beginning and you find that there is no further small a's, then what you need to verify, you just need to verify that you have matched the same number of a and same number of b or same number of z or not. So how would you come to know? Once you are at this point, once you are at this point, and next symbol is, instead of small a, next symbol is y, it means everything you have converted to the x. Now you see that there should not be any small b here. Instead you just have the symbol y, and immediately after completion of the y you must have the symbol, sorry, this is y, and you must have the symbol z. And after the once symbol z is over, then you should have the symbol right angular bracket, and hence the same number of a, same number of b, and same number of c you are going to match. So you can say like this, what you are going, say you are having this tape. So at the beginning you have the initial, at the initial level, this is the initial tape conditions. So this is the initial tape contents. So initial tape content is like this. Now during the process, of the input in the LBA, your tape may contain different symbols. So this is the square 0, and you have the blank symbol. Okay, so you are having A, okay, then you have the B, C, C, and then you are having the right angular bracket. So how we can process? So we are starting from the initial state. So at the beginning, this is the initial state Q0. From the initial state, since your tape head is scanning the symbol at the square 0, you just go to the input. So you have to scan this. So you add the, if you are at the state Q0, you have the symbol and replace with the same symbol. You are not changing, you are not allowed to change. Go to the state, say you are going to the state Q1. If you are going to the state Q1, then in the state Q1, you will have A. So whenever you are having the A, so whenever you have the A, you are going to change with, if you have the A, replace this A with X and go to the right. So you are going to replace with X. So this A is, you are having the, you have replaced with X. Once you have replaced with X and go to the right, so your right is at this place. So you are at the state, say you are at the state Q2. Okay, you are at the state. What you need actually, you may have some more number, you just need to go to the first B. So you have the small a, you may have the small a. So just if you have the small a, you can just scan. So if a is, small a is there, replace with the small a and go to the R. So you are going to the right. Whenever you are going to the right, you are scanning to the right, and you have the B. So you have the A here. Then here actually you are not changing the A. So this A is remains same. Once you are having the B, as soon as you have the B, what you need to do, you are going to change with different symbol. Say you are changing the B with the symbol, say Y, and you are moving the tape head to the right. So you are changing the B. You are not changing A, but you are changing B to Y. So once you are changing B to Y, so this B you have changed to the Y, and you are moving to the right. Once you are at the right, you have the symbol B. So you are at, say for example, you are at the state Q3. Once you are at the Q3, then you may have some more symbol B. So you are going to the right, and right you may have some more B's. So you just skip. So B is replaced with B and go to the R. So this is the situation. Whenever you are going to the R, you may find the, so this is B. You don't require to say anything, do anything. Whenever you have encountered the first C, this is the first C, you are going to change. So assuming that, okay, you can go to this place. See this is the Q4. You are going to the Q4. From where? From Q3, you are going to the Q4 for what? So you have B, you are changed to the Y, and you are moving to the right. You are scanning for the B. As soon as you are encountering the C, so whenever you have the C, replace this C with some other symbol like Z. And what you need to do, again come back to the beginning for replacing other symbol. So you are coming back to the left. So here you are not changing the B, but you are changing the first C, and first C is changed with Z, and you are coming to the left. Once you are coming, this you have changed, and once you are coming to the left, you have the B. You may have the B. So you are, in this case, what you are having, you have the B small b. So what if you have the small b, replace with small b and going to the left. So you are moving to the left. So you are moving to the left, and when you are, so you have the b, you are moving to the left, and now this b, once you go to the left, this b you have changed to the y, so you may also have the y. So you can have the y also, to replace with y and come to the left. So y you are also scanning. Once you are coming to the left, you may have the small a. So you have the small a, replace with small a and come to the left. So here you have the small a and come to the, once you are coming left, then you are scanning for the small a, and then you will find that x here. So once you are having the x, go to the right to change the next a. So once you are having the, so from, you can say, from state q4 you are coming to the q1. When you are coming to the q1, whenever you have the x, whenever you have the x, replace with x and go to the right. So you are right. Once you are at the right, so you are here, and this is what, whenever you are here, whenever you are at the right, you have the small a, and this small a you are changing to the x again, and you are moving to the right. Once you are moving to the right, then now you have to mention for the y also to reach the small b. So you can say, if you have the y, replace with y and go to the r. So this y you are also scanning and go to the r. So whenever you have, either you have some further a, or you just have the y, so you are going to the r. Whenever you are find the b, so you have seen here you have the b, again you are changing this b with the y. So you are changing this b with y and you are moving to the right. So b with y and moving to the right. And once you are the right, so you are, here you have the z, because earlier you have converted this first c to the z. So for reaching to the next c, you have to scan the z also. So you can say that if there is z, replace with z and go to the r. So use this z, you are going to replace with z and you are going to the right, and as many z you may have, go to the right. Once you are encountering the c, then you have to replace this c with z and come to the left. So you are coming to the left. So c with z and coming to the left. Now what you need to do, you are scanning, you are coming back to the previous places at the beginning where you may have some more a's, so you have to scan back. So once you are coming left, you have the z, and so you have to mention for the z also. So z, replace with z and come to the left. You can also do. So you have replaced with z, come to the left. Once you are at the left, you have the y, and replace with y and come to the left. Again you have the y, replace, you are not changing the y, come to the left, and you have the x. As soon as you have the x, go to the right. So once you are the right, so whenever you have the x, go to the right, means you are at this place now. Now see, whenever you are at that place, so what you are having, you have the uppercase y, instead of a you have the y. This means all a's have been converted to the x. There is no more a's, means this is the number of a's you have. Now you need just to verify whether the same there is some more b or some more c left. If it is not, then your task is over. So just verify now. Now you are going to verify. So how you are going to verify? You are just see that this is, say for example, q5. So you have the state is q5. So you have the q5, and what you are saying, you have the y. So you have the capital Y. Replace with y and go to the r. Okay. So just once you have the, once your head is scanning the symbol y, you just scan, you just replace y with y, means you are not changing the y. You just go to the right. You may have some more number of y. You just scan, replace with y and go to the r. And what you need, after the y you should not have the small b, otherwise this is the situation of cases. Means this, if you have the small b, then there are more number of b's you have not converted to the y, but you have all converted to the x. So whatever same number of symbols you have converted, whatever number of a's you have converted, the same number of y and z are here. So if you have some more small case b or small case c, then this is the situation of crash. So what you are scanning for y, go to the right. We want only y here, that's why you have to mention y. Once you scan completely y, then you have to scan z. So after the y you should have the z. So you are replacing with z and going to the right. So you are scanning z and going to the right. Say if you are here, again scan z is replaced with z, go to the right and right. Once you are going, you have the symbol right angular bracket. So this, once immediately after the uppercase z you have the symbol right angular bracket, this means you don't have extra c's here. So this is the situation of the, this is the situation of acceptance. And hence if you have the symbol right angular bracket, you are not supposed to change this symbol, replace with the same symbol, and you may keep the tape. You cannot move the tape head to the right, either even you can move the tape head to the left, but you should not jump right off the symbol right angular bracket. So that's why you have to keep the tape head stationary, or you can keep the tape head left move, there is no issue. And your machine is halting in the state HA. So see, this is the LBA. This is an LBA. This is an LBA for the language what? For the language AN, BN, CN, where n is greater than or equal to 1. So whatever the input is given, so you have seen that your input, your tape head, your tape head is bounded by that much number of symbols in the input. So this is the, from here you are supposed to work from here to here. For the double A, double B, double C, you can work from there. So whatever the length of the input x, the region is bounded on the tape, and within that length actually your tape head is moving back and forth. So you are not, you don't require more tape, more squares beside these squares, and that's why this, the regions are bounded. So if you have the language which is the context sensitive language, then you don't require actually more space to work. You just need the space that is the length of the given input. So on the length of the given input, whatever be the length, and this much number of square you need. Okay, so for this case you have 6, the length of this is 6, and you can work within the square, within the 6 number of square, and these 6 is number of squares can be manipulated, can be written with the different symbols. Beside these 6 symbol squares, you have 2 squares, which is the boundary of this input. So your input is bounded by these 2 symbol. So you have the left angular bracket and you have the right angular bracket. So you have the bounded by the regions. Okay. So now we have seen that if you have the, if your language is context sensitive, then we have the LBA for this case. Okay. So for every context sensitive language, we have the LBA. Okay. So that's so this is also, this is the model of computation. LBA is the model of computation for accepting the context sensitive language. And we know that every the language which is the context sensitive, they are recursive also. So every context sensitive language is recursive. So we have the LBA For the context sensitive language means we have the recursive language, and for the recursive language you have the device which is the LBA. So if you have some context sensitive language, we will have some LBA. Okay. At home, you can, as an exercise, you can take some different context sensitive language and try to construct the LBA for those context sensitive language, and you can practice like this.